Hey there, PoA. It's at the end of another really good day in our class. I think the best yet again. So we're still continuing to improve, which is really nice. People are following directions a lot more precisely today, and the disruptions were, they got smoothed out by the end of the hour, which was nice. I think we got a lot more done, which is great. So let's take a look at this homework. So we're talking about patterns and sequences, and patterns, again, are something that we're looking at where we can predict the next thing that will come based on what we see. And so a sequence is just a pattern with numbers, so we need to make some predictions. That's what this next three terms business is about. So I'm going to zoom in here. Forgive me as I get used to this program. This is my first time using it. So this first sequence, I see 1 and then 3, then 5, then 7, then 9. If you remember today, we talked about thinking about how do you get from the first number to the next, and so I know one way to go from 1 to 3 is just to add 2, and so that add 2, that plus 2 is 1 plus 2 gives me 3, and then it seems like I can do the same thing again. Plus 2 is going to give me 5, and then plus 2 is going to give me 7, and plus 2 gives me 9, and so from there, I think I should just keep adding 2, and 9 plus 2 is going to give me 11. Add 2 again, I'm going to get 13. You get 13 when you add 2 to 11, and then 13 plus 2 gives you 15. And so when I come over here to write the explanation of the pattern, well, I know that I'm just adding 2 each time. You might also say that those are the odd numbers. If we look back here, I see 1, 3, 5, 7, 9. Those are just all the odd numbers in the sequence there. So let's look at this second one, 0, 2, 1, 3, 2, 4, 3. And that one's a little bit more difficult. And if you recall, the third pattern we looked at today wasn't just a simple addition or multiplication. It involved a little bit more thinking. So to go from 0 to 2, I could do that by adding 2, and I'm just guessing and checking here. And then I'm going to go from 2 to 1, well that's a minus 1. And then 1 to 3, there's a plus 2, and that's a nice sign because I've already got a plus 2 here, and so it seems like there's some repetition. Then I subtract 1, and again that's a repetition of this previous pattern, so it seems like we add 2, take away 1, add 2, take away 1. And so there's plus 2 to get 4, minus 1 gives 3, and so if I look at the pattern here, it's 2 plus 2 minus 1 plus 2 minus 1 plus 2 minus 1, and so the next step should be a plus 2 step here. And so 3 plus 2 gives me 5, and then it should be a minus 1 step after that, so I'll go to 4, and then a plus 2 step gets me back up to 6. So again, that's plus 2 to get to 5, minus 1 to get to 4, and plus 2 to get to 6. And it's okay to make those notes on your paper. Math is messy sometimes. And so for my explanation of pattern, I'm going to write it adds 2, then subtracts 1. Alright, let's go back. Alright, 17, 12, 7, 2, and minus 3. And so I went from a positive number here to a negative number, so that makes me think that I might be taking away stuff rather than adding stuff. And there was some subtraction in the last problem. So 17 minus 5 gives me 12, and 12 minus 5 gives me 7, and 7 minus 5 gives me 2, and minus 5, 2 minus 5 gives me negative 3, and so that seems like it's the pattern. If you're not sure how to find out what the difference is between 17 and 12, you can't just do that in your head. You could do 12. You could do 12 minus 17, and you get negative 5. And we're going to talk a lot more about that later this semester, but that negative 5 is that minus 5 that we're seeing. And so I'm going to take negative 3 minus 5, and that gives me negative 8. And I'm going to do negative 8 minus 5 gives me negative 13. And then negative 13 minus 5 gives me negative 18. And they're just negative numbers, nothing to be frightened of or concerned about. Hopefully nobody's run for the hills at this point. And so now I'm going to explain my pattern. It takes away 5 each time. And you could say subtracts if you want, or decreases. Any of those things are fine at this point. Alright, so let's look at this next one. I see 8, then 4, then 2. The first thing that comes to mind for me is that 4 is half of 8, and then 2 is half of 4. So I'm kind of thinking like maybe it gets cut in half each time. And the same thing as cutting in half is dividing by 2. And so maybe it divides by 2 each time. And so I'm going to check the pattern to see if it works. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. And then 1 divided by 2 is 1/2. In fact, that's exactly what that fraction says. And so I'm going to continue dividing by 2. 1/2 divided by 2 gives me 1/4. And you might be doing this on a calculator, and you might get 0.25. And then 1/4 divided by 2 is 1/8, and again that's going to be 0.125, and then it should be 1/16. I think I'm just going to do a calculation here. And that should be on a calculator 0.0625. And you can give either answer there. It would be just fine. You might notice that as the fraction gets divided in half, the denominator, the number on bottom, doubles. So 1/4, and then 4 times 2 is 8. And so for a fraction to get half as big, the denominator has to double. So let's explain that pattern. It is divided by 2 each time. Ooh, some more negative numbers now, so let's take a look at this one. So negative 35, negative 28, negative 21, negative 14. And I'm looking at that, and I'm thinking, you know, these are all if I remember my 7 facts, these are all multiples of 7. So like 7 times 5 is 35, and 7 times 4 is 28. So I think there might be something ongoing here where if I add 7, I'll get the next term. So negative 35 plus 7 is negative 28. Negative 28 plus 7 is negative 21. It seems like it's working. Negative 21 plus 7 is negative 14. And so that seems to be the pattern. And again, if you're not sure how to figure that out, you can take a sequence and subtract one term from the previous term. So I could do negative 28 minus negative 35, and it should give me plus 7. And so that's a way that you can figure out what's going on there. I'm actually just going to erase that because we don't need it here actually. So negative 14 plus 7 is going to give me negative 7. Negative 7 plus 7 gives me 0, and then I'm back in the positive. 0 plus 7 is 7. And so I'm going to explain that pattern now. It adds 7 each time. Okay, last pattern here. 1, then 2, then 6, then 24, then 120. This is a particularly nasty one, I think. It's kind of a weird multiplication pattern. So 1 times 2 gives me 2, and 2 times 3 gives me 6, and 6 times 4 gives me 24, and 24 times 5 gives me 120. And so when you're looking at that one, that's pretty darn difficult to figure out. And this is kind of like the pattern John was noticing in class today, where it seems like there's a pattern in what's happening to the numbers each time. Or it seems like we're multiplying by something bigger each time. So I'm going to multiply by 6 next, because we multiply by 1, 2, then 3, then 4, then 5, and 6 seems like the natural next thing. That's 720 that I get. And then I'll multiply by 7, and I'll get, I think, 5,040. And then multiply by 8 this time, because it's 2, 3, 4, 5, 6, 7, 8. That's 40,230. And so when you're thinking about that one, you can think of an addition pattern, and it doesn't seem like there's an addition pattern, because plus 1 gives you 2, plus 4 gives you 6, and then plus 18. That's kind of a weird jump to take. It's hard to find a pattern there. And so then you just keep on experimenting till you see what you see. In this case, it's just multiplication. Sometimes patterns just take a lot of concentration. And so the explanation, I'm going to write it multiplies by 1 more each time. Okay. Whew. That's number 1, all done. That was a lot of work. All right, let's see if we can look at one of these visual patterns now, because I see this growing dot sequence. Now the first thing I notice is they all kind of appear to be the same pyramid shape, but what seems to be happening is that the pyramid seems to be getting a little bit larger each time, and it's precisely getting larger by having one more row. And so I see that there's 1 and then 3, and then this one has a 1 and then a 3, and then there's 5, and this is 1, 3, 5, and then there's 7 dots. So I think the next one should have 1, 3, 5, 7, then 9 dots. And then it's going to have all of the other dots as well, so then I'll have 7 above it, and then 5 above that, then 3, and then 1. And then figure 5 I'm going to draw down here because I'm kind of running out of space. This one has 1, 3, 5, 7, and so this, and then 9. And so this next one should have 11 on the bottom. And I'm going to make this one a little bit squished because I'm running out of space. 3, 4, 5, 6, 7, 8, 9, 10, 11. And 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, and then 1. And so I continue to have that big pyramid or triangular shape, but there appears to be an extra dot in the extra 2 dots, one on each side, in the row that follows. And so now it says, starting with figure 1 and using the number of dots in each figure, list the first 5 numbers in the sequence. And so I think what I'm going to do, I'm just going to count the dots. So I see 1 plus 3 is going to give me 4 dots for figure 1. So I'm going to write figure 1. And so I'm going to go ahead and make figure 3, figure 4, figure 5. Okay. I'm just using one of those organizational principles that we talked about in class the other day, making a nice table here. So I see 4 dots, and then the next one, 1 plus 3 plus 5, is going to be 9 dots. And then the next figure, I add a row of 7 to that, so that's going to be 16. And then I add a row of 9 to that, so that's going to be 25. And then add a row of 11, I get up to 36. And hopefully this is starting to look an awful lot like one of the sequences we looked in class at today. In fact, John described it for us. I think what he said is that you add 2 more each time than you did before. And the two more that we're adding are the 2 on the end here, so I could point to this dot and this dot. That's the 2 more that I'm adding than I did previously. So I add 7, and then also 2 more to get to add 9, and then I add 11 after that. And that's how the pattern is growing there. Oops. All right, let's keep on moving down the page here. So use your pattern to determine the number of dots in the 8th figure of the pattern. And so again, these are all about being able to predict. So I'm going to continue my table here. I'm going to do 6, that's figure 6, 7, and then 8. And so I know this is my number of dots down here. I had 36, I'm going to add not 11 but 13 this time, and I'll get up to 49. And then I'll add 2 more than I did before, that's plus 15, is going to give me 64. And then I'm going to add 2 more than I did before, that's plus 17, and I'll get all the way up to 81. And we're done with the first page. Way up. Alright, on to the back page here, and we have some of these lovely shape equation puzzles again, so we have to do a little bit of thinking to think about what it could be that could fill in for these shapes. And so what I notice is that if you take this diamond and you add to this triangle, they add up and they make 16, and so what I'm thinking is that if you look at this part right here, where there's a triangle plus a diamond, that's the same as a diamond plus a triangle, so that part of the shape equation puzzle is 16. And so that part alone is 16, and so that means that whatever's left over, 16 plus the triangle, equals 21. Okay, so now we just have to think of what you can add to 16 to get to 21. And I think it's just got to be 5. And so that means that 5 plus 16 equals 21. And so therefore, triangle equals 5. So I'm going to put that down here. And so now I'm going to go back to the other puzzle, and I'm going to fill in. So instead of diamond plus triangle equals 16, I'll put diamond plus, instead of triangle, I know that's 5 now, plus 5 equals 16. So I need to think of what can I add to 5 to make 16, and to my mind that means that this has to be 11, so the diamond is 11. And so I'm just going to double check to make sure I'm right. So I do 5 plus 5 plus 11, and that does give me 21, so it checks out with the first one as well. So it seems like we're in good shape. So let's look at this pattern in the table here. I'm going to zoom in a little bit so I can write on these little table lines here. So I see a clear pattern here. This is just adding 1 each time. That is pretty straightforward. So I don't have to worry about that. That pattern is already taken care of. Nothing interesting going on. So maybe there's a pattern over here. So the first thing I try is addition. How do I get from 3 to 7? Well, I can add 4. And I'm just guessing and checking. Hopefully this is right. So then I try it again, plus 4, that does give me 11, and so now I know my pattern is going to be plus 4 each time. You can remember from class today we talked about how you have to have the first 3 terms of a sequence to know what the pattern is so that you can test your hypothesis about this step on the next step. And so 11 plus 4 gives you 15, plus 4 gives you 19, plus 4 gives you 23, and plus 4 gives you 27. So we're going to describe the pattern here. I'm going to say I tried adding 4 each time, and it worked. So that's pretty much what we did. We tried it and it worked, and so that's what we think the pattern is. Just adding 4 each time. So let's come down here to the map of Texas. And I can't actually recall at this point if this one is on your homework. If it is not, then you can skip ahead a little bit in the video to get to number 5 and number 6. But it says, on a map of Texas, the distance from Abilene to Midland is 10 centimeters. The map scale shows that 4 centimeters on the map equals 50 miles in real life. So that when you think about a map scale showing that, it's telling you a ratio, so every 4 centimeters is the same as 50 miles. And when you're thinking about ratios, you can write 2 ratios to make a proportion. So the way scales work, and I'm thinking about this word scale here, the way scales work is that you have a consistent ratio of some measurement on the map to some measurement in the real world. And so if you know that on the map it's 10 centimeters, say from Abilene to Midland, as it is in the problem, then it's got to be some particular set of centimeters. I'm just going to put, let me erase that here. I'm going to put a question mark here for the number of miles. And so if I think about what I can do to get from 4 to 10 centimeters, this is just one way that you should know from maybe your 7th grade curriculum about how to solve proportions. I'm going to go from here to here. 4 times 2.5 gives me 10 centimeters. And if you didn't know that, you could always do 10 divided by 4 gives you 2.5 to figure out what you multiply by. That means I have to keep it in proportion, multiply by 2.5 right down here. And of course, 50 times 2.5 is 125. So it's 125 miles to keep it in proportion. So if you were driving it in the real world, you'd have to watch your odometer click over 125 times. Let me get rid of that mark there. Okay, let's take a look at number 4. So it says there are 6 boys to every 9 girls in the 6th grade. And so this phrasing, 6 boys to every 9 girls, that's actually ratio phrasing as well. So I'm going to write 6 boys to 9 girls. I know that just from reading the problem so far. There are a total of 75 students in the 6th grade. How many boys are there in the 6th grade? Ooh, they're twisting it on us. So we don't know the proportion of boys to total students unless we think about it like this. There's only boys and girls in the class, and so 6 boys plus 9 girls equals 15 students. And so that means the ratio could be 6 boys to 9 girls, but could also be 6 boys to 15 students. I'm just going to write stud. So that's got to be equal to some number of boys that we don't know, because it asks you how many boys. So question mark boys to 75 students. Again, I don't know how many times 15 goes into 75, so I'm going to do 75. Whoops, I'm writing a different number. Might have just had a stroke. 75 divided by 15. Going to do the calculation here. Is 5. So that means this multiplies by 5. I'm going to write that in different colors so you can kind of see the thinking here. This is times 5. So this must be times 5 as well to keep the ratios in proportion. And so 6 times 5 equals 30, and so there are 30 boys. Alright, and we're almost done. Only a couple more problems left. So we're going to order these decimals from least to greatest. Alright, so I see a 7 right off the bat. That is a pretty big number compared to the rest. In fact, I'm going to scan through. That is 7 holes, and the rest of these numbers, none of them have a hole. So I'm going to go ahead and put this number 7 all the way over here on this side because I know that's the largest. Now we need to look and see what the next smallest is. And so when you're thinking about decimal numbers, you have to compare digits. So I'm actually going to rewrite these. So some of them have 2 digits after the decimal point. That one does. Some of them have 1 digit, and some of them have 3 digits. And what I like to do is I like to write them all out so they all have the same number of digits, and then you can kind of compare them because then it's easy to see which one's largest and smallest. So going from the front, this is 0.620. Again, if there's nothing after 62, then it's just a bunch of zeros after 62. 0.380, and this is 0.900. And you can see that it's starting to look a little bit easier let me clean that up a little bit. Because 620 is obviously bigger than 380, which is obviously smaller than 900. So it's becoming a little bit easier to see which numbers are larger here. 540 now, 0.600, and then 0.720, and whoops, that's 270. And 0.106, that already has 3 digits, and 0.003. Okay, and so now I'm going to use letters and put them in order. So 3 is obviously, if we just think of these as like big 3-digit numbers now, 3 is obviously the smallest of those. And then the next one, our largest, is 106, and then we get up to 270. Then it jumps to 380, and it jumps to, looks like 540, and then 600, and then 620, and then 900. Okay, so I'm just using the letters because it's another way of my thinking about the ordering here. So now I'm going to look at A. I'm going to list A first. So A is 0.003, that's the smallest. And then 0.106, that's the next smallest. And then 0.270, which is actually, as it's listed, is just 0.27, so I'm just going to write 0.27 there. And then after 0.27, I go from A, B, C, I'm going to go to D now. That's 0.38, and then 0.54, and 0.6, and then 0.62, and then 7. I've got all my numbers ordered from least to smallest, and something that I tried to make sure to do is that as I rewrote them here, in this area over here, I made sure that I wrote them in the form that they were written in the original problem. And that's something that is helpful to your graders, and it's also something that standardized tests will look for. Alright, so last problem. A rectangle has a length of 3 1/5 yards and a width of 7 5/6. Make a sketch of the rectangle and label its dimensions. So rectangles look like so. And so I know that the short side is 3 1/5 because 3 holes in 1/5 is smaller than 7 holes in 5/6. And so it asked me to estimate the area. And so estimate means that I don't have to have an exact thing. So I'm going to do my work in red or maybe blue here to try to think about how this works. So 3 1/5, well, it's only got one part of 5, so that's about, I'm going to use this symbol, that's about, it's not equal to, but it's about 3, and that's going to be my estimate for it. 7 5/6, that's 5 out of 6 parts, that's almost a whole, so that's almost 8. Area you do by doing 3 times 8, or length times width, so 3 times 8 equals 24. So now let's do the exact calculation in black. This is a little bit trickier. So in order to do 7 5/6 times 3 1/5, it can get a little bit hairy if you don't remember to convert your fractions into improper fractions. So 7 5/6, that's 7 times 6 plus 5. 7 times 6 is 42 plus 5 is 47, so that's 47 sixths total times, and then I will do this, 3 times 5 plus 1 gives you 16 fifths, and so all I did was I took the number of holes times the number on bottom of the fraction, that's this part, that gives me 7 times 6 is 42, and then I add to it the parts, which is 5 there. And so 7 times 6 plus 5 gives me 47 sixths. So 7 5/6 is the same as 47 sixths, and 16 fifths is the same as 3 1/5. And then when you multiply fractions, you just multiply across on top and bottom. And this is where it gets really lousy. 47 times 16 is a crazy number, 752. And then 6 times 5 is 30. And so I can compare this number to what I get down here. I'm going to go ahead and convert that to a decimal. Divide by 30 is 25.06 repeating. And so you can see these two numbers actually end up pretty close together. So that's the homework for, I think it was lesson 1.5. Hopefully you learned something from it. Thank you so much for watching this video. If you did, and we look forward to seeing you in class tomorrow. Take care.